Wazowski. Mike Wazowski. Don't forget to take attendance.
That may be my favorite new filter. Are you ready for math? Get ready to take notes. You're going to do so good. Take the notes, do the practice page, do all the things, and I'll be back. Just imagine, you could be me right now, getting needles put in my hip, bzzz, burning them off. But just think, maybe it's going to work, and maybe I'm going to be in so much less pain, and it's going to be wonderful.
Okay, let's get started with our area of rectangles and parallelograms. So last week we focused on rectangles. This week we started with parallelograms. And so now we're going to take some notes so that we have some reference sheets that we can check back on, as well as some information about the formulas and different ways that we can indicate the units for area. All of this is kind of a review, so this is the perfect time to sit back, take the notes, and then we can put it into our binders as our reference. So area of rectangles. Area is the surface measurement. So surface measurement of a two-dimensional figure, okay? So that means it's a flat figure. It's like something that's laying down on your table on a piece of paper. It doesn't have any upwards width to it or height to it like a box would have. So it's just a flat square, rectangle, parallelogram, circles that are all just laying flat on your paper. That's what we're referring to when we're talking about a two-dimensional shape. We can think of this as square units that a shape covers. So how many squares are inside that shape? And again, all review, we've talked about this. To find the area of a rectangle, we use the formula of A equals BH. And I want to reiterate this. The B is the length of the base, and the H is the height of the rectangle. And so this is where I'm going to have you sketch a rectangle off to the side, okay? And it all just kind of depends on how the rectangle is situated. So it doesn't matter which side it's sitting on. Whatever it's sitting on is considered its base, and then whatever is going up and down vertically is our height. And we could have a situation where the base is actually a smaller unit of measurement or a smaller amount than the height is. The height might be taller than the width of the base. But regardless, we usually think of base as the bottom, so what it's sitting on. The area is measured in square units. Okay, so again, it's how many squares fill up the inside. So if you want to, you can try to sketch in even squares into that box you made. And so we're talking about how many equal squares fit inside of our shape. If I'm multiplying inches times inches, my area is going to be inches squared. So how many squares that are 1 by 1 inch each. If I'm doing feet, it's going to be feet squared, and then meters squared. And you can actually use any of those distance measurements for area. It's just depending on how big you want your square units to be. All right, for this first section, we're going to count the number of squares. When it's on a grid, we want to count the number of squares if it's an easy amount of squares to count. We've seen some situations where there's just a lot of them, and so we're going to actually do this in different ways. And so I'm actually going to start with rectangle 3. I know it's kind of counterintuitive, but the reason I'm starting with rectangle 3 is because it's actually the smallest of the units. And so for this one, this is a situation where counting and checking off as you go is an okay strategy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I already know that my area is 16. It doesn't say any specific units, so that's when we're going to use our generic units squared. So I know that that's my answer. But we can double check to make sure that we got the correct answer by using the formula of area equals base times height. So my bottom, remember, we're counting from corner to corner. That's 1 unit. So that's 1, 2, 3, 4 units is my base. So I'm going to label that. And then 1, 2, 3, 4 units is my height. And plug-in values literally means that instead of me, I don't know the area yet, but instead of me putting the B in, I'm going to put 4 in its place. I'm going to put that dot for multiplication because that's what BH means. It's base times height. And then I'm going to put my other 4 in. And then I can put another equal sign and say, hey, yep, that is 16. So I'm confirming my answer. Now, in situations in rectangle 1 and 2, counting is actually would be my backup plan. So counting would be how I would double check my answer. But again, if you miscount, you make a mistake. So the less counting we have to do, the better. So let's go ahead, and we know we're going to use area equals base times height because it's a rectangle. So let's count my base, 1, 2, 3, 4, 5 units. 5 is my base. And then my height, 1, 2, 3, 4, 5, 6, 7. So 7 is my height. Let's plug those values in. So my area is 5 is my base times 7 is my height. On your multiplication chart, put your finger on 5, put your finger on 7, bring them together, and we get 35. So my final area is 35 units squared. Now double checking my answer. Double checking my answer would definitely involve me counting, but there's an easier way to count something like this. So we're used to counting by 5s. So here we've got 5 across. So 5, 10, 15, 20, 25, 30, 35. So that's an easier way to count the square units is just counting by a number. If it's 5s, 2s, if you can count by 3s, 4s, all of those. But that's just a quicker way to do the counting. Rectangle 2 is my largest rectangle, so counting, we could easily make a mistake on that. So that's why I'm really going to focus on the base times height method. So area equals base times the height. So let's count it. I prefer, instead of hopping from corner to corner, I actually put a tick mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's less movement. It's a little bit easier to count across by just putting that little tick into each of the units. So 9 is going to be considered my base. My height, 1, 2, 3, 4, 5, 6. So 6 is my height. Let's go ahead and do our plug-in values. So area is going to be the base is 9 multiplied by 6 is the height. Using your multiplication charts, put your finger on 6, put your finger on 9, and then drag them straight across and straight down until they meet to get 54 units squared. And that'll be our final answer. Okay, so we're going to fall off the grid now. So when we fall off the grid, that means that the only option that we have is to either draw the squares in, which is not a practical thing because you don't have a ruler most of the time, but the most practical thing is to go ahead and just multiply and do our formula of base times height. Again, we identify the formula is going to be for a rectangle, so base times height. Then we're going to identify that even though 8.6 is on the top, opposite sides of a rectangle are equal, so 8.6 centimeters is the base, and then 3 centimeters is the height. Now, we are actually going to do the math out on this just to be practicing that decimal multiplication, so we shouldn't be using our Chromebook calculator. We shouldn't be using the calculators on our tables. We should be doing the multiplication out together, so I'll do that with you. But our base is 8.6 multiplied by, and you notice that my dot for multiplication is in the middle, not like my decimal, it's up in the middle. So that's how you tell the difference between multiplication symbol and the decimal symbol, times 3. Okay, so to do this, I'm going to have to set up a 2 by 2 or a 2 by 1 digit multiplication. If I can get my right pen. We're going to do 8.6 times 3. The good thing with decimal multiplication is we just ignore the decimals until the very end. So we're going to do individual multiplication. So the first thing I'm going to do is my 1. So 3 times 6 is 18. I carry the 1, I drop the 8. Then I'm going to do my next one. So 3 times 8 is 24. I'm going to add the 1 on top, so that's 25. So I put the 25 down next to the 8 because I have nowhere else to multiply or carry to, so we're done. We have 2, 5, 8. Now, we have to go back into the original problem and count how many digits came after the decimal. In this case, there was 1 digit after the decimal. So in our final answer, we're also going to have 1 digit after the decimal. In this case, it's the 8. So our final answer for this one is actually going to be 25 and 8/10. And you have to keep in mind that this is no longer just units, this is centimeters squared. So we have to make sure we're using the correct unit of measurement. Okay, let's go on to number 2. So number 2, we're gonna use the formula for a rectangle. We're gonna do base times height. My base, again, opposite sides are equal, so my base at the bottom is 9, and my height is 7. So we're going to plug that into our formula. Instead of base, I'm going to put my 9 times, and my height is 7. Using our multiplication charts again, 9 times 7, 63. So our final area is 63 feet squared because we're using feet as our measurement in our original rectangle. All right, so there is a situation where we can also solve for any missing piece of information in a formula by solving a one-step equation. We're not quite at that point yet. So I'm going to go ahead and I want you to just cross this out with me because we're not quite at that piece where we're going to talk about that. That's going to be further on. Go ahead and flip over your paper and we're going to take a look at use our understanding of area to answer the questions. So these ones are the ones that we're talking about where we would use a one-step equation, but instead of that, we're going to actually cross out the 162 meters, and we're going to put base equals, let's say 7. Actually, no, definitely not 7. Base equals, we'll say 21. Base equals 21. So this is just us doing some more practice instead of doing the one-step equation. So the area is, again, base times height. And so in this situation, we actually have to do a 2 by 2 digit multiplication problem. So again, give yourself some space. We're going to set up 21 times 18. And we're going to go step by step. So the first thing I do is I do my 8 times 1 is 8. And then 8 times, and that's actually 20. So 8 times 20 is actually 160. So that's why we put the 1s and the 6 next to the 8, because that's in the tens and hundreds place. When I move on, I'm done with my 8. Now I have to do my 10. That's 110 in the tens place. I actually am going to put a 0 to hold that place. So there's the 10. There's my 1. There's my 0 down here. That's the 10. So I'm going to go again and think to myself, 1 times 1 is 1. Okay, but that's really 1 times 10. So that's where our 10 comes from. And then 1 times 2 is 2. But that's actually 10 times 20. And so that's where the 210 comes from. So we're talking about our place value being in the correct spot. These are what we call partial products, so we need to add those up. So 8 plus 0 is 8, 6 plus 1 is 7, and 1 plus 2 is 3. So based on our measurements, when we did our 21 times 18, our answer ended up coming out to be 378, and it's got an M on it. That's for meters, so that's meters squared. Okay, question number 4, we're going to go ahead and cross out question number 4 because, again, that's that one-step equations. I'm not looking to do that with you this time. So just cross that one out. Let's move on to area of parallelograms. So we started off by talking about how parallelograms, a rectangle is a special kind of parallelogram. And so we're going to talk about how the formula is actually the same. So the dimensions of a parallelogram are also referred to as the base and the height. And we use the same formula of area equals BH, base times height, where B is the length of the base and H is the height of the parallelogram, which makes a 90-degree angle with its base. And so we're going to kind of show what that is in the next couple of examples, because it's very important that you identify the correct base and the correct height of the parallelogram, because if you don't, you're going to get the incorrect answer. So looking at this, we did this in our Desmos, where the parallelogram is cut right here. Okay, so this is the original parallelogram. I'm going to draw it in red so you can see it. So this is the original parallelogram. But what we're going to do is we're going to take this piece, this triangle on this end, and we're going to actually go over to the other end, okay? And we're going to tag it onto the other end. So even though I'm cutting it off and I'm moving it, the area is remaining the same because it's counteracting it. When you take something away, but then you add it back onto the same thing, nothing actually changed because you did opposite inverse operations. And so we're still going to use the base times height formula, but we do need to count the base out. So 1, 2, 3, 4, 5, 6. So 6 is my base, and then 1, 2, 3, 4 is my height. So let's plug in those values. Area equals 6 is my base, multiplied by 4 is my height, for a total area of 24 units squared. In parallelogram 2, we have 3 measurements, and this is where we have to be careful. So we said that base is on the bottom. Well, right now we've got the 9 on top is opposite of the 9 on bottom. So we can fill that in. Opposite sides of a parallelogram are equal. We also have this 4 that's going up and down, and then this 5 that's on this slant. And this is where you have to be careful. Because once we pick the base, so if I decide this is my base, 9 centimeters is my base, I have to go at a 90-degree angle straight from the bottom of my base up to the top of the opposite base. So that 90-degree angle is what matters. This 5 is at a slant. That's not at a 90-degree angle. So 5 is the number that we're actually not going to use. We're going to use 4 as our height. So this 4 is our height. So let's go ahead. We're going to use base times height because, again, this parallelogram could be rearranged. We could take this triangle and move it to the opposite end and finish the rectangle off. But we don't have to do that anymore because we've identified that a rectangle and a parallelogram are the same. They're just rearranged. And so we're just going to go ahead and use the formula. So area equals base is 9 times the height of 4. So using your multiplication chart, put your finger on 4, put your finger on 9, and bring them together to get an area of 36. And in this case, we're talking about centimeters squared because they did identify centimeters as our unit. Okay. Parallelogram number 3. So we've got some decimals in here, and that's okay. We're still going to do them out together. Just going to take our time with it. A parallelogram still has the base times height as my formula. My 2 is my base. And I know that it's my base because it's got its height connected by a 90-degree angle. So that's how you're going to identify that, is you're looking for the 2 lines that are connected with that 90-degree angle. And then you'll have your base and your height. So let's plug that in. Area equals 2 is my base times 1 3/10 is my height. But again, I have to set that up as a 2 by 1 digit multiplication. So I'm going to put the 1.3, so more digits on top, times 2. We're going to ignore the decimal again. So 2 times 3 is 6. 2 times 1 is 2. And again, we're going back into the original problem there's 1 digit after the decimal. So that is where my decimal will go, is I'll have the number 6 after the decimal. All right, so 2 6/10 feet squared is the area of my parallelogram number 3. All right, our last little bit, we're going to do our word problem. So Mrs. Lewis asked students to sketch a figure with a base of 12 inches and a height of 6 inches. Did the students complete the task correctly? Describe how the area of a rectangle and the area of a parallelogram with the same dimensions are related. So the rules were simply that you had to have a base of 12, which Seth and Nikki both did, and then you had to have a height of 6. Well, remember that a rectangle is a parallelogram because it has 2 sets of opposite, equal, and parallel sides. And there's a right angle at it, so that's connecting the height. So in this case, his height is 6. And in the parallelogram, Nikki drew the 90-degree angle, went from base to base, and that is also a height of 6. So both students did meet the requirement. So yes, both shapes have the same area because they use the formula area equals base times height. And so if the base and the height are exactly the same, they will both end up having the exact same area. We do have to call attention to that they're both in inches. So take a second to finish writing that down. And then the next part of this video is going to be the practice problems. So here's where we can split off into 2 groups. The substitute can pause the video, and if you would like to continue following along with me, you can open up your Chromebook, and it is posted on Google Classroom, and you can do the practice page with me. So the next page you're going to get from the substitute is the practice page. It says homework. It's really just practice. Okay, so you don't have to panic about that, but it's practice. But you can continue watching independently on your own Chromebook in Google Classroom to follow along if you want to do these problems with me. If you feel like you can do this independently, then all you have to do is get to work on it, but it should be a voice level 0 to 1. Okay. If you are going to do it with me, we're going to start at question number 1, of course, and it's going to be, you can pause this if you want to try it by yourself, do it, and then check your answer, do that. That's a great way to try and do it kind of independently, but still with me as kind of that buffer that can help you see if you got the correct answer. So we identified that it is a rectangle. We are looking for the area. We are looking for the area of a rectangle. So let's write our formula of area equals base times height. And our plug-in values, we're going to identify 12 as our base, 6 as our height. So area equals 12 times 6, and you can use your multiplication chart for that. I personally like to count by 12s just to practice that. 12, 24, 36, 48, 60, 72. So I know that 72 and feet squared is going to be my units. You can also set it up as a 2 by 1 digit multiplication. So 12 times 6, 6 times 2 is 12, 6 times 1 is 6, plus the 1 is 7. So multiple ways that you can solve that. All right, this one does have decimals in it, so you do have to set up a multiplication problem with decimals, which we'll do together, but base times height. Identify our values, so our base is 12, and the height of our parallelogram is 3.7. So remember, area of a parallelogram has the same area formula. So we just need to make sure that we're identifying the base and the height that meet at a 90-degree angle. Okay, so let's set this up. We're going to do 3.7 times 12. We're going to set it up as if it's a 2 by 2 digit multiplication problem. We're going to ignore the decimal until the end. So 2 times 7 is 14. 2 times 3 is 6, plus the 1 is 7. And then the next part of my multiplication is 10 times bigger. It's in the tens place. So I'm going to put a 0 as a placeholder because it's 10 times bigger. And then I'm going to do the same thing. 1 times 7 is 7. 1 times 3 is 3. And I need to make sure that I'm continuing to maintain those place values as I do this. After I do my 2 separate multiplication problems, I'm going to add the partial products together. So 4 plus 0 is 4. 7 plus 7 is 14. So I'm going to carry the 1, drop the 4. And then 1 plus 3 is 4. So it looks like we have 444. But my original problem had a decimal in it. So again, we count how many digits are after the decimal. There's 1. So we're going to go ahead and put 1 digit after the decimal. So 44 and 4/10 is what we end up getting. So my plug-in values was 3.7 times 12, and my final answer was 44.4, 44 and 4/10. And I got to zoom out so I can see meters was my label. So meters squared. All right, here is a tricky one. So the parallelogram, we know that the formula is the same as a rectangle, so base times height. But we have 3 different measurements that are showing up. So which one is the correct base, which one's the correct height? Looking at this, you're looking for 2 measurements that meet at that 90-degree angle. If you look here, this is not a square, okay? This down here is not a square, so we're not meeting at a 90-degree angle. This 2.2, it looks a little weird, but if I go straight down and straight out, that's that 90-degree angle we're talking about. So inside the parallelogram, the height is here, and it is 2.2. So my base is 8, even though it's up on top. Remember, the bases opposite are equal, so the base is on bottom. It's just it's labeled up on top. And then my height is 2.2. So we're going to do my plug-in values of 8 times 2 and 2/10. But I'm going to put my more digits on top when I'm doing the multiplication. So I'm going to put the 2 digits up on top and then put my 8 underneath the 2. And then we're going to multiply that. Remember, ignore the decimal. 8 times 2 is 16. Carry the 1, drop the 6. 8 times 2 is 16, plus the 1 is 17. We do have to look back at the original problem. There is 1 digit that comes after the decimal, so there is 1 digit that comes after the decimal. My final answer is 17 and 6/10. And it's centimeters squared because my original measurements were in centimeters. All right, now we've got a rectangle. Rectangle is still base times height. Let's identify. So this is where some kids get confused because they're like, no, Mrs. Lubowski, we've been doing the base is the longer of the 2 sides. Well, it's not necessarily the longer of the 2 sides. In this case, the base is sitting at the bottom. 2.5 is the base. Our height is 15. And that's okay because multiplication has the multiplicative. It has, we can flip-flop our multiplication. So we have the commutative property that says I can change the multiplication factors and still get the same answer. So regardless of whether I label 2.5 as the base or 15 as the base, we'll still get the correct answer. So let's go ahead and plug in those values. So area is going to be 2.5 times 15. And they both have 2 digits in them, so it doesn't matter which one goes on top, which one goes on bottom. We're going to set it up as 2 by 2 digit multiplication. And let's go ahead and do it. 5 times 5 is 25. Carry the 2, drop the 5. 5 times 1 is 5 plus 2 is 7. All right, This number is 10 times bigger, so we have to put a 0 to hold my place value. Let's do our two problems. 2 times 5 is 10. And I crossed that 2 out because we've already used that. We carried it, and then we added it on the last problem. Then 2 times 1, oh, don't forget to put our 0, drop the 0. 2 times 1 is 2, plus that extra 1 is 3. Now we add the partial products. 5 plus 0 is 5. 7 plus 0 is 7. And 3 plus nothing is 3. Don't forget to look back at your original problem. We've got our 0.5, which means there has to be one digit after our decimal. So I'm going to put that one digit after the decimal. And our final answer is 37 and 5 tenths, or 37 and a half inches was our units squared. Okay, a broken rectangular shaped window is being replaced. It measures 24 inches by 18 inches. How many square inches of glass are needed to repair the window? So let's go through and mark this problem up because it's a word problem. A broken rectangular shaped window is being replaced. It measures, circle the 24 underline inches by 18 inches. So those are the measurements. The question is, how many square inches of glass are needed to replace it? Now here's the tricky part. Square inches tells me we're looking for the area. At no point does it say find the area. So you have to understand that when they ask for square units of some kind, they're implying that you're going to find the area. The next thing you want to do is sketch a picture. So I'm going to sketch a rectangle. I'm going to pretend that I have a rectangular piece of glass or a rectangular place to put a window. 24 inches by 18 inches. And because I'm trying to figure out the number of square inches, which is area, I'm going to use the formula of area equals base times height. Base is my 24. 18 is my height. So let's plug that into 24 times 18. This is another 2 by 2 digit multiplication that we need to set up to complete. 8 times 4 is 32. You're going to hear the announcements in the background.
All members of the Trailblazer team.
Do not go down to take pictures. I can't help that they interrupted my video. All right, 32, carry the 3, drop the 2. 8 times 2 is 16 plus the 3 is 19. There's nowhere to carry it, so I drop them both down. I'm done with the 8. Now I do the one that's 10 times bigger, so I put a 0 to hold my place. 1 times 4 is 4. 1 times 2 is 2. We already used that 3, so we're not adding that in. Add the two partial products together. 2 plus 0, 2. 9 plus 4 is 13. Carry the 1. 2 plus 1 is 4. And this one did not have any decimals. So our answer actually is 432 inches squared is the amount of window we need to replace that. Okay, a parallelogram is being painted on the wall of a playroom. The parallelogram measures 7.3 meters in length and has a height of 5 meters. How many square meters of paint are needed? So again, we're going to go through, we're identifying that we're doing a parallelogram painted, and the parallelogram measures 7.3 meters in length, but that's the same as the base, and then it has a height of 5 meters. It's a really big parallelogram. How many square meters? So again, it's asking us the question of how many square meters. You have to know that square meters is referring to area. So right here, this is asking about area. So we're gonna sketch a parallelogram, just put it on the slant. 7.3 meters on the base, the length across, and then the height, draw the height with me. We have to go at that 90-degree angle straight from the bottom up to the top, so to the opposite base, and that's 5 meters, which is my height. So let's plug this in. Area equals base times height, so 7.3 times 5. Let's set that up, 7.3 times 5. 5 times 3 is 15. 5 times 7 is 35, plus 1 is 36. Looking back to the original problem, there is one digit after the decimal. So we're going to put one digit after the decimal. 36.5 meters squared is how much paint you're going to need to do that. All right, I'm going to challenge you to look at that last one on your own and see if you can identify where did they make the mistake. And if you're not sure, look back at your notes, because there's one key detail that they made the mistake on the parallelogram. Look specifically at the parallelogram notes.